Hello everyone, today I'm gonna record a Kickstart guide for using Geodot, the one of the plugin for Godot. So basically Geodot is a plugin for loading geospatial data to Godot that can be further used as image tester. There are many other features as well. Um, to begin with, we need to download one of the successful builds from the repository. So as you can see here, we already have a Docker file um, ready. So a Docker file could automatically Dockerize the whole build process. So it will include install the dependencies and then run the build for us. To see all the existing builds, we can go to the Actions tab. Mm-hmm. Scroll down once we found entry mentioning cross-compiled Geodot for Windows friendliness. That's the one that we want to use because currently I'm using the Windows system. You can also use other builds like the builds for Linux and Mac OS. So we can go to this build and then click the artifact here so that it will be downloaded to your computer. Um, Once you have it downloaded, you'll be ready ready as you'll be a folder named geodot-plugin. So if you now go to the folder, you can see all the dependencies that's really included. Specifically, those are all the build files. So you can copy the whole uh, build files to your own project. But for this demo, I'll be using the existing skeleton of this build because it has already included a raster demo here. So once you install this, we can try to open it in Godot. Hmm. It's loading. We we can open the scene called raster demo. So that's the one we're gonna use. Click the play arrow there, and we can see that the whole scenery or the image has been rendered on into the game. Um, to tell you more detail about how it works, we can go to the mesh instance 3D here, go to the mesh and go to the material. Basically, the Geodot plugin would supply the resource for this file. You will load the image tester to the author, which is basically the whole picture of the tester. The height map is the thing you can see the terrain, the change of the height. Just a quick demo again. You can see that the terrain has already been included, so you can see the height change, which is a very interesting feature. Now that we wanna replicate this demo, we can use by using our own raster data. For this demo only, I'll be using the one from City of Waterloo. There are many open source and open data that are provided by the municipal website. We'll be using the Arrow Imagery 2021. Once you have downloaded something similar to that, it might not be the exact format that we want. So typically we want a TIFF file or GEOTIFF file. Other formats like PNG could also work. But in this case, we might need to transfer our data formats from .xid to TIFF. So I'll be demoing that as well. Basically, I ask ChatGPT about how to do that. Basically, we can use the GDAL library for it. It's basically GDAL library also was one of the internal tool that's used by Geodot. According to the tutorial provided by ChatGPT, we can download a GeoViewer, which is very handy to view and then export .sid files to other formats. Basically, SID file means where is it? It's basically means it's a Mr. SID arrow image format, which are very concentrated data formats. So if you want to get a TIFF file, it might be much more larger. So we can open the Geo Viewer now. We can click File, add local layer, select the imagery we just downloaded, use the default map projection. This might be very helpful in the future. So we can document the imagery here. We will be using we use later. So we can zoom to an area that we want to extract. Click on Tools and Export. We can select the current view, so the data size might be smaller. Once you click this, go to this screen, we can select the right raw file in this wizard. So after it has been exported, the raw file will provide us some basic georeference data that we need. Okay, so for this demo, I have already downloaded to and extracted to another folder here. So here's the image too. That's the file that has been exported. We can view the TFW, which is the raw file. I will open it with the notepad. So the two lines below here is actually the coordinates of the top left pixel in the map projection of NAD, the default map projection that we use here. The current one we are using is NAD83, UTM zone 17M. So this coordinates actually the coordinates for this map projection. So we can take note of this. So now we have the image in TIF format. We can actually import it into Geodot. I close the one that might be confusing. We can open the script of the raster demo and change the start position S to be the one here, which is the coordinates S of the top left pixel, and then we copy this to be the coordinate start position Y. You can make a few minor changes so that you can extract the exact image that you want. So you can tweak them a little bit. The next two parameters we want to set here is the size in meters, which is actually the actual meters, the width and the height of the image that you want to extract. For this demo, I use 1 kilometer, so that's a good coverage of the area. So the image exported will be 1 kilometer times 1 kilometer. The actual size. It's more like the georeference size. So the boundary of the width of the image is like 1 kilometer. The next parameter is the size in pixels. So it's actually determined by the resolution of the image. For the image that I just downloaded, it has a 10 centimeters resolution. So that means for every pixel, it covers the width or the length of 10 centimeter. What that means is that for every pixel, it represents 10 centimeter. To convert the size to pixels, we just need to multiply the meters here by 10. So for every meter, I forgot how I did the translation. Then I think I asked ChatGPT to get a exact result. Um, Let me check. Oh yeah, here's the solution that was provided by ChatGPT. So, so basically just multiply by 10 for this case, and you can also ask ChatGPT this question, and the bot will provide you with an answer. Hmm. So we have all the 4 parameters set. So those are the parameters that we need to display the image correctly. For this demo only, we don't need the height map data, so we can just delete the relevant code from the script, leaving only the author data path, and we can copy the path to the image here, so that it will be displayed later. Okay, I would like to give it a try and show you how it works. Okay, so here's the demo. Here's the GeoGuessr time. Do you happen to know what this place is? If you know, feel free to leave a comment in the video, which is actually pretty cool. I can imagine there are many potentials of using this plugin for making games. Typically, many location-based games use those kind of technology. It might actually be more useful or more powerful. As we can see, we can render raster data here, but yeah. In the future, I'm thinking about make some contributions to this open source project, like make the map rendered by tiles, especially if we have some kind of spatial index system. So for the rendering of the image, we can actually load it by additively, so that might save a lot of the resources for the computer. Okay, I think that's all for my demo. If you have any questions, feel free to leave a comment, and thank you very much.